So the first thing I did was to measure out 2.128 grams of salicylic acid. I went ahead and put that in a Erlenmeyer flask. To that I'm going to add 4 mils of the acetic anhydride. This is the anhydride that I had mentioned earlier. Once I add that, the 4 mils of that to the flask containing the salicylic acid, then I'm going to add 5 drops of concentrated sulfuric acid. Swirl that, and then I'm going to clamp it to a clamp and then lower it into this boiling water bath, and we'll let it stay in there for about 10 to 15 minutes. Just swirling to mix the reagents. And it's not uncommon for there to be some solid. It should dissolve once we start heating it. And we'll give it a 10-15 minutes, and then we'll turn off the heat and continue from there. It's been 20 minutes, and so I've taken the flask out of the boiling water bath, and what I'm going to do next, I've got 10 mils of chilled water. So and the purpose of adding this, you just want to add a little bit at a time. So I'm going to add about 2 mils at a time of this and swirling after I add it. This is to decompose any of the acetic anhydride that did not react. So I'm going to add some of that and then just kind of swirl it. And you certainly want to do this under the fume hood because you don't want to smell the acetic anhydride or the vinegar that's really produced as well. And then what I'm going to do now, we've kind of got this where it's kind of tempered, if you will, a little. I'm going to put this in an ice bath and let it sit there for about 10 to 15 minutes, and then we'll come back and pick up from there. This has been sitting in the ice bath for 15 minutes. So what I'm going to do now is take this and add 25 milliliters of chilled solvent, which is the water that we're using. And then I'm going to take a stirring rod and just kind of break the solid up. If there's any lumps, I kind of want to crunch those out, because what we want to do is we're going to wash this. Once I filter this, we'll wash this with some cold water. You always want to wash the sample with chilled solvent, just in case if it's at room temp, it could actually dissolve some of your sample, but you can see where the solid there is. It looks pretty finely dispersed. So now what we're going to do is to filter this through a Buchner funnel filtration. I also have some chilled water that I'm going to use in addition to what I've just added to the flask containing our product, but I'll leave that there. It's cold enough now. So when you use a Buchner funnel filtration, you have your funnel and you have your suction filtration flask that has a side arm. What we're going to do is connect the tubing to that side arm, and then it's always a good idea to put some type of container underneath where the faucet comes to help reduce the splashing. So you always want to put a piece of filter paper inside the Buchner funnel, and this piece of filter paper needs to fit this correctly. If holes are exposed, then you're going to lose material. If it's creeping up the side, let's say this was too big and it was creeping up the sides of the Buchner funnel, then you're going to lose some material because some of your material can go underneath where it's creeping up the side. So it needs to be a flush fit. And then what we want to do is to add some distilled water, and actually I can add some of this that I've got here just to wet the filter paper. Once we wet the filter paper, typically you just turn on only the cold water faucet, but because of sink issues we have here, I need to turn both faucets on to get the best suction. So I'm going to add a little bit of water just to wet the filter paper. And then I'm going to turn both faucets on. And I like to kind of just push a little bit on this to make sure there's a good suction. And then what I'm going to do is swirl this, and then I'm going to pour it over top of the filter paper. And then I'm going to add some more of this chilled solvent, the water. I see some solvent kind of clinging to or some of the solid. I'm just going to see if I can loosen that up a little bit. It's probably going to be impossible to get every little crystal there. There's a time where you say enough's enough, if you will. I'm not really measuring how much I'm using. I'm adding it to that same Erlenmeyer flask that we collected our product in. Notice there's no solid in the bottom of the flask, so we haven't lost anything as far as the solid going straight through. Now, when you disconnect the apparatus, you never want to cut the water off first. You always want to disconnect the rubber tubing first. Before I do that, I'm just going to get a spatula and kind of push down on that. So I'll be right back once I get that spatula. I'm just going to kind of push down on the solid that's in here, just to kind of squeeze, if I can, any last traces of moisture. And you can see that it's still wet, so I'm going to kind of scrape that back into the Buchner funnel. It looks like most of the liquid has gone through. I don't very seldom see any drops here. So what I'm going to do now is you want to unhook the rubber tubing before you cut off the faucet. And the reason for that is if you cut the water off first, then the vacuum that you have here can suck up the water that's draining and go through and come back into your filter flask. Now, we're not collecting this to do anything much with as far as another reaction, but if you were going to save this, the last thing you want is it to be contaminated. Now, what I'm going to do is I want to squeeze the solid between pieces of filter paper that I have laid out here. So you can kind of see where this is what we've collected. So what I'm going to do is I'm going to transfer the solid onto clean, dry filter paper. Now, I know in the lab book they said to weigh the filter paper before you did the filtration. That filter paper is going to be wet, so that really the wet filter paper is not doing me any good as far as getting a weight. Now what I want to do, I am just going to put a couple more pieces of filter paper over top of this, and then I'm just going to squeeze it to see if I can get any moisture out that might be trapped within those crystals. And I may need to do it twice. I'll kind of get an idea of how many times I need to do it based on what I see on the filter paper left behind. If I see where it looks like there is some moisture, and I just want to make sure I scrape everything back off. I think I'm going to do it one more time. I do see a little bit of wetness on this piece of filter paper. So what I'm going to do is I have a couple more. Ideally, it would probably be good to kind of put this in an oven and dry it for several hours. Don't really have that luxury today. And I think that's pretty good. I'm not seeing any moisture that looks like it's absorbed onto the filter paper. So what I'm going to do is I'm going to transfer this to a weighing dish, and then we'll come back with a weight of how much we actually got back. So the next test we're going to do is the iron chloride test. So what I'm going to do is, we've got 3 separate test tubes, one of which is going to serve as our blank. So I'm going to put about 1 ml of ethanol into each of these. Then I'm going to go back and add a few drops of the iron 3 chloride, and this one will be our blank. So that will have nothing but the ethanol and iron 3 chloride. Before I add the iron 3 chloride to here though, I'm going to go ahead and add to the first test tube salicylic acid, which is what we started with, and then I'm going to add to the second test tube a few crystals of what we prepared today, the aspirin. Then I'll go and add the couple drops of the iron 3 chloride. So what I'm going to do first is just fill this with the ethanol. I'm going to go ahead into this last test tube and some of the iron 3 chloride solution. And again, this is just serving as our reference. So if there's a negative test, then this should stay that yellowish color. So this is our blank or standard. So what I'm going to do next is to put in the first test tube a few crystals of the salicylic acid. I like to add the sample before I add the iron 3 chloride, because I just want to make sure that everything dissolves. I think you get better test results when the sample does dissolve, or mostly dissolves. Now remember, for salicylic acid, what do we have? We've got a carboxyl group, and then we also have the phenolic group. So to that, I'm going to add a drop or two of the iron 3 chloride to see what happens. Looks like one drop is about all I need. And if you notice, the solution turned that purple color. What does that tell us? That tells us that there had to be an OH group onto the benzene ring. So this is the material we started the reaction with, which should have the purple color when tested with the iron 3 chloride. So now what I'm going to do is I'm going to take some of our sample that we collected, and then I'm going to take a little bit of that and put that into a test tube that contains the ethanol. Again, just kind of want to see if that can dissolve as much as possible, so it mostly did. So now what I'm going to do is add a drop of the FeCl3. Now let's take a look at this. We see that there was a color change, obviously, so we know that we have some OH group present, but compare it to what we have, you can tell that there is a difference. So the presence of that purple color tells us that there must be some unreactive salicylic acid. Should that surprise us? Not really, because remember that it is an equilibrium-based reaction, so we may never get all of this converted. So it is possible that some of that stayed behind. Even after washing, this really isn't soluble in water, so it's not going to be removed from the water layer. So if any of it was still there, we would see it. But very little, and I added about the same amount of solid to each test tube. So faint positive test, I would say. You can tell that there is some, but not very much because of the intensity of the purple color. Next thing we're going to do is we're going to heat some of our sample in a test tube with an open flame, and then we'll see if we can detect the presence of the vinegar. So what we're going to do now is to take some of our sample of our acetyl salicylic acid, i.e. aspirin, and we're going to put it into the flame for a few minutes, and then I'm going to see if I can detect any odor associated with that. And I smell vinegar. So what does that tell us? That tells us that with the heat, we have our the acetyl group, the newly formed ester link, hydrolyzed, if you will. Remember, this is still a little bit moist, hydrolyzed in the presence of heat. I can tell the formation of the vinegar. So we know that we formed our product, even though we had slightly purplish color here. Majority of our product is assumed to be the acetyl salicylic acid.